Well, hello, gentlemen. Welcome to Mining Now. This is our first on-site here. We're at the NORCAT Underground Training Centre. We're going to be featuring Rogers today. I'm not going to try to do a technical intro, so I'm going to let you introduce yourselves. Paul, you've been on the show a couple times.
I have. Great to be on the show again.
Yeah, and Shaun, this is your first time doing the show with us.
Happy to be on the show today.
Just a quick intro of your positions at Rogers.
Paul Howarth. I'm the Senior Director of Advanced Services for Rogers Communications.
And Shaun Mohammed, Senior Manager of Business Development for Advanced Solutions for Rogers Business.
Paul, let's start with you. And this is just a conversation where we can sort of jump back and forth, so you guys can kind of feed off each other. But we're going to be moving around at different locations here at NORCAT. Can you say sort of where we're standing now, and we're going to bring up some footage for the audience to see what we're actually looking at?
For sure. So we're going to walk the audience today through all the technical aspects and components of a cellular network. So what we thought we'd do is start with an example of an outdoor tower. And we've got a small one here at the NORCAT Centre. What the audience will be able to see on the top is very, very typical. You'll see several radio units up on top and a large pizza-sized dish. That's actually the microwave unit. So this tower is actually fed from another radio unit way off in the distance, which is not unusual, particularly in a mining use case where you can't always get fiber optics on site. Microwave is kind of our go-to to get that backhaul, they call it, connectivity.
So you're connecting off an outside cellular system, this one, and so we're going to walk through sort of multiple layers, right down to how you can actually get connectivity inside the mine.
Yeah,
right?
Exactly. This is an example of an outdoor unit, but when we get in the mine, you're going to see all the same components. Some of them will look a little bit differently. We don't need to use microwave underground. Underground at this center, we'll have fiber optic cables connecting all the components together, and then ultimately, this facility will allow you to go out to the internet or make a Microsoft Teams call or a TASTA push-to-talk call, all from underground using a cellular network from Rogers.
And Shaun, we're going to actually do that as part of this interview later on. You're going to be on a different location within the mine site. We're going to do a call. Can you kind of walk?
Yeah, so we're going to do a push-to-talk call over cellular. So Paul will be you at one location, and I will be in a different drift. And I'll do a call and we can communicate. And we're also going to do a call out to our colleague Claude in Montreal from underground.
Okay, I want to just safety is such a big part of the discussion around mining. So I wanted to walk through it from and apologies if I'm using the wrong terminology, but the telecommunications side of it. Can you walk us through the safety element of the on-site here?
Yeah, it's a really great question. So cellular networks have number one, some safety regulations. The technical term is Safety Code 6. So there's certain power ratings and distances that you need to stay away from operating radios for safety reasons, and those are all defined within Safety Code 6. So as Rogers, we would have a radio engineering team look at all the infrastructure above ground and below ground and make sure that we can put the radios in places that keep people a safe distance away or tell us how much power we can use. So these radios that we have on the surface can be quite powerful. We wouldn't use those underground. Underground, you'll see something that's called a small cell. We would tune those all the way down to low power, very similar to a Wi-Fi signal for safety reasons. Other things to think about is telecom equipment in general is often powered from two sources. So when you're thinking about doing a lockout for power and safety reasons while you're doing work on that equipment, you need to make sure how is that equipment fed? It could be AC power, it could be DC power, there could be a UPS in the background between it. Not unusual to have telecom because it's so important to safety. You want your telecom working, but it could have those dual power sources in there, and you want to make sure that you've got them both disabled if you're doing work on that type of equipment.
Shaun, when we were actually driving here to site, I flew in from BC this morning, and we were driving in, and you were talking about some of the questions. I heard some of the questions that clients were actually asking you. When we walk through this project, will this answer a lot of common questions that clients have when they're trying to get connectivity on site?
Yes, it will. So it will show them the design and implementation of a network, how it would look in a site, industrial site similar to theirs, right? So we'll show them ubiquitous coverage from above ground to underground. So right now we're standing next to our small cell, which is providing coverage for both the private network and public network. And when I walk underground, I will still have the public private network coverage, and I won't disconnect. Right. So a lot of mine operators and a lot of industrial sites, they want to know when I move from one part of the property to the other part, if I will still have connectivity or I will drop and reconnect. And the answer to that, it will be ubiquitous.
Yeah, that's actually a huge technical problem a lot of industrial customers face, particularly if you're working underground. Yeah, they want to know that, hey, I have connectivity and it's private for security or operational reasons on the site, but there's often reasons they need to connect. So in a mining scenario, when you're underground and you're coming to the surfaces, they start to use autonomous equipment. As they're using things like push-to-talk, they want to know that that connectivity will be seamless. So what we're doing here at NORCAT is actually quite unique. We're demonstrating the ability to be on the surface like we are today, attaching to an outdoor cell tower and be able to go underground and actually have the same connectivity regardless of where we are.
Yeah. Well, this is probably the time to move underground then. All right.
Sounds good. Thank you.
Good.
Okay, gentlemen, we've moved inside now into the actual mine. So, Paul, I think I'd like to start with you on this one. We're going to be bringing up, I'm calling them clusters, probably not the right terminology, but can you walk us through some of the hardware similar to like what you did outside, some of the hardware we're seeing in this part of the mine?
Sure, Jerrod. So what, now that we're underground, you're going to see many of the same components. Underground, we don't need the microwave dish that you saw because all of the equipment down here will be interconnected using fiber optic cables in this particular facility. But the rest of the components, you're going to see we've got both 4G and 5G antennas. Those are the small panel antennas, the little squares that you can see up on the ceiling. Behind those, they're now plugged into the radio unit itself. So those two components are taking the analog signal, they're transmitting the analog signal. They're powered up at the ceiling themselves. In this case, they're AC powered, but they can also use DC power. The fiber optic cables from that cluster are now then fed back into our head end, we would call it. Inside the head end, you're going to see the rest of the radio equipment. So when I talk about the radios, we got antennas. You've now got the radio unit itself, and then there's something called the baseband. All those components make up sort of the totality of the radio system. At home, your listeners are probably more familiar to something like Wi-Fi. All those components are inside that small Wi-Fi, but in a cell network, they're broken apart because they need to be more powerful. They need to be able to handle more users. So for example, a 4G radio, we can have 100,000 devices on a 4G radio. On a 5G radio, which we also have in this particular facility, you can have 1 million simultaneous devices. So they're really built to scale. And so inside our head end room here, what you can see is there's two cabinets. On the right-hand side, lots of blinking lights. Those are the basebands. The radio units, we have 8 in this particular facility, are each coming back through fiber optic cable to that baseband. It's that baseband that's allowing us to have that many devices, all the throughput that you might need for.
It's taking them into individual, I mean, I'm sorry for the really layman way, but it's like individual streams of.
It's taking all that analog data and it's digitizing it, and it's able to do it, like you're saying, simultaneously across thousands and thousands of connections, where something like Wi-Fi has all the same components. It's just not designed to have that type of scale. And so the performance starts to drop off as soon as you get 5, 10, 15 devices using any type of throughput. That's really just the difference. They're all the same components. One is designed to scale much further, and that's really what we use in our cell networks here. So all the blinking lights are the basebands. So we've got antennas. And actually, there's one more component that's not here underground that I didn't mention on the surface. All cell networks need a GPS signal. We use that for clock. Mobile devices plus the radios and moving between cells takes exact synchronization. So a GPS is what gives us that clock signal. That would be up on that cell tower outside, and we'd retransmit that signal underground to give us that synchronization that we need for proper cell phone communication. So you've got your GPS, you've got your antenna, the radio unit, fiber optic cable, going back to your baseband. Now you have your complete radio system. Now we want to do something with it. So the cabinet on the left, very similar, lots of blinking lights, and there's servers in there. That's where we're running what's called the packet core. And that could be a 4G core, it could be a 5G core, it could be 4 and 5G. This particular one is designed as a 4G core at this facility. That takes all the information and sends it out to wherever you want it to go. That could be the internet, that could be your private data center. Wherever you want us to send the location, we'll direct it from the back of this cabinet out through your particular facilities. The packet core also takes care of all the subscriber information. So you don't want just anybody getting onto your cellular network. And because this is private by nature, the core has all the subscribers. So there's a whole database in there saying this SIM is allowed onto this network, this SIM is allowed to communicate here. So the core takes care of all of that functions. And it's worth noting, I'm using the word packet core. There's really no such thing as one individual component that you buy that's called a core. There's actually, it's made up of several different components, but in the industry generally called a packet core. So it has subscriber databases, it has P gateways, S gateways in a 4G world. But for simplicity's sake, we'll just call this the packet core. It's the brain of the system that takes that radio data and allows you to transmit and receive.
I just wanted to clarify something. We're talking a lot about communication, but this is also communicating with like devices and sensors and gathering data. That's facilitating all of that. Do I have that right?
That's correct. In fact, cellular networks are used ubiquitously for communications. I think we all know text messaging and voice calling, but in an industrial setting, it's usually not about that. It's usually just about some type of IoT sensor or an IoT gateway on a vehicle, wanting to check temperature, water, location, speed, all that telemetry information that you might want to use and collect on your devices. So in an underground environment, it's really important to know what's going on at the mine face. Are they finished with the drilling? Are they ready for the next crew to come down? All that information is invaluable to a production team to know when to send the next crew there, how far are they progressing on that particular step within their project. And that's something that cellular networks are really built for, right? That mission critical, reliable connectivity that needs to be on all the time.
I wanted to, Shaun, ask, again, going back to the question I asked outside, that sort of the customer question, like we're inside a mine here. When you're talking to we're talking underground mines specifically, but it's maybe similar, but specific to the underground mines, what are their concerns? What are their questions when they're trying to figure out if they can even put a system in place?
So the biggest question and concern we get is coverage, because we're in a mine. It's a harsh RF environment. A lot of mines have tried mesh Wi-Fi and they haven't gotten the performance that they needed, so they look to LTE or cellular. So in this particular facility, Rogers has over 40 years of deploying and designing networks. We manage thousands and thousands of radios. Yeah. With our partner Ericsson, we came out here and we took what is called a digital twin of the mine. So we drove this little robot around and it captured images of the mine. They put it together and provided us a 3D image or a digital twin of the mine. From that, we were able to design where the coverage within the mine. So we knew where we were exactly going to place the radios, how we were going to angle the antennas to get the coverage that we needed. In this particular facility, as we walk here, there's a corner where NORCAT had challenges getting connectivity. So they would say it's a blind corner because once you go around this corner, you couldn't get connectivity. So we decided this is one where we're going to showcase how LTE and 5G is different. So we mapped it out using the digital twin. We ran different scenarios of if we place a radio here, if we place a radio on this side, will it drop or will it hand off seamlessly? And I could say that that corner has full coverage now. Now, within the mine, based on safety rules, we had to create certain what we call dead zones, and that is because of ISED regulations around blasting caps. So once again, with the digital twin, we ran a simulation of, okay, if we put the radio at this height, at this angle, this particular location, we'll be able to make sure the signal doesn't travel to the area with the blasting caps, because you can't have any type of coverage in there.
Right. So are the radios, are they, either one of you, the system that the first system we looked at, the one around the corner, is it going to be a duplicate of that system, or is it going to have differences?
It's a single system. Everything is interconnected. So it's one, but physically it can be the same or it can be different. It really depends on how much power and the particular use case. What you're seeing here is called a small cell. That's where we can tune the power down to something that's safer to be around workers in a particular facility like this. And then you're seeing different types of antennas. So there's an omni antenna along with some directional antennas that you saw on the outdoor facility. Down here, you're looking at a combination of panel antennas. And then you'll also see leaky feeder cable. That's a long cable that we also run off the same radio that's here. Looks just like a long, thick cable where we could leak signal.
That's in that, we were walking by that, we're actually gonna walk down there in a bit.
And you'll see that particular aspect. And there's just different use cases. So we don't always have to extend the radio right to the area where people are working. We can use different antennas that plug in. There's trade-offs, of course. When you're using the panel antennas like you saw in our cluster, we can get the most performance, the most throughput. When we're using leaky feeder, we can get into sort of those long, twisty, windy places like a drift would be. You don't get as much throughput or performance out of that type of cable, but it tends to be cost effective. And usually what we see is some combination of both. Really depends on the type of area inside the mine. Often an older part of the mine that there is no active mining anymore, they might have leaky feeder in there. So when they have to visit that area occasionally for safety reasons, or maybe they want long-term sensors in there to collect data about that environment, leaky feeder is perfectly fine for that. But on the working end of a mine, you might want small cells closer because they're looking for more performance. So it really all depends on the environment. And our RF engineers can, as Shaun mentioned, they can help decide. When you tell us, what kind of performance do you need, where do you need the coverage, they're going to go into their tools and kind of look at what that environment looks like. And then based on our experience of where we've put radios before, we'll make a recommendation, and then we'll come out and test it and make sure that we're achieving the results that we expect.
Again, Shaun, maybe we'll toss it over to you. The components are when they're in an active mine. How are they protected? Again, we're going to show some of the footage, or sort of what can they take as opposed to dust, active equipment, that sort of thing.
So the equipment that we use is temperature rated to go from -40 to +40, right? So the temperatures in an underground mine, yes, it does get a little bit hot. Thank God today it's not. Yeah, it's nice. So as you can see, we do have a AC unit to help keep the temperatures in the room a little bit cool, because the equipment does give off a lot of heat. Normally these for NORCAT here, we're using so we can showcase the equipment. We would normally use a mesh cabinet like this because you can get some dust in it. So it would be in an intrinsically safe cabinet. So you limit dust, and so you're protecting the equipment from dust and the other elements.
Yeah, and often, in some cases that equipment can be located on the surface, can be underground. We use a lot of containers. They look like a shipping container, but for many of our customers, we're putting a power system, batteries, all that server type equipment in an enclosure. We're pre-building it, and then we'll ship to the site where there's already a pad in place, so we can keep a very sort of intrinsically safe environment, like Shaun mentioned. And then keep in mind that these radios are the same radios we would use in the far north, in the southern part of the country. They're all meant to be outdoors in the first place, so they're meant to get wet. It's not unusual for them to get covered in ice and see all the extremes of the weather that we have inside Canada. And of course, in a mine, you see not so much the extreme cold temperatures, but in some particular facilities, but underground, it's more heat and water. But the radios are already built for that type of environment in the first place because we operate them outdoors.
Well, we know we're in an operating mine because we can actually hear gear being fired up in the background, which is actually perfect. Yeah, no. Yeah, exactly. No, it's like we planned it. Paul, I just want to quickly do a clarification. You were mentioning, and again, I'm sorry for the sort of the layman setup for these questions, but the 4G and the 5G. So this system is it's like both?
It's actually both. It's a great question, and it's even confusing for us in the industry. So we're operating both 4G and 5G radios here, and the way we're doing that, it's something that's called NSA, so non-standalone mode, is how we do it. So we're using the packet core that you see on the left-hand side, but it's both interconnected to 4G radios and 5G radios. And in this NSA mode, the connection will start on 4G very quickly, and then the 4G hands it off to the 5G radio if the device is capable of handling that type of performance.
Right. Okay. So, I just wanted to clarify that. So, and Shaun, we're going to bring in Greg Major, and he's going to he's just going to talk a little bit about the maintenance, give us a little bit of scope of the actual, like, the mine that we're in. And then I keep messing up the terminology of what we're going to do with you to sort of wrap up the show.
Yeah, so we're going to talk about the applications that's running on the private network underground here.
Yeah,
how it's leveraging. We're going to do a real world live call, and we're going to show you some sensors in action.
And we got a crew coming in the back. I don't know if you can see it on the camera. So we'll step out of the way and bring in Greg. Greg, we pulled you in here from NORCAT. What's your role here?
So I am the director of the NORCAT Underground Centre.
I should have said your full name, Greg Major.
Yeah.
So I just wanted to, we got you to step in here quickly for us because I wanted to understand from the NORCAT side, just on the maintenance. This facility obviously has a lot of maintenance that is required.
Sure.
On the communication side that Rogers has set up, that's pretty limited.
It is limited. Thankfully, the mine itself has a lot of work to just keep it legal and safe and sound. The maintenance for this project, for the Rogers technology, very easy. It's monitored 24/7. I've got a hands-off situation. I've got control if I need to, but it's not required. So when I get clients in here that need support while they're doing their technology testing, the support's there. It's low maintenance.
What's the support from Rogers' side? I'm sure as you're onboarding any system, it's the supplier that you're hoping that you can actually talk to them. They're on site here today. Can you sort of walk us through that part of the experience?
So if a client is inside doing tech testing and they're tech testing here, they're working on a project that requires the new Rogers technology. Limited support from me. Rogers support person will be here on site. Rogers support
coming
person,
on site for it.
if required. I mean, these guys want this to survive or to succeed too, right?
Yeah.
So for me, I can do it. We can work with them. We can be partners and make sure our clients are good and healthy and safe. But Rogers is jumping in there and making hands free for me.
Yeah, which is quite nice for walking around this facility.
I've got enough maintenance on my own without worrying about the extra stuff, right? So it's a pretty good technology and it's maintenance free for me.
Yeah, we're going to walk through. We're actually going to be walking through we did it a little bit with Paul and Shaun, but can you just sort of give just a snapshot of the facility that we're at here? The audience is going to see us walk through some of it.
Sure. So the NORCAT Underground Centre has been operational since mid-90s. It is first started out as a skilled labor training. So we trained people how to be miners. About 8 years ago with Don Duvall's joining the team, we said, hey, we need something else in the north. Technology testing center. It was right down our alley.
Right.
We had empty drifts with technology that was waiting for these companies to try it out. An empty drift doesn't make me happy, doesn't make me any money. So that's what we did. So some of our work is skilled labor training, some of it is technology testing. Got basically 3 kilometers of drifting. We're a hole in the mountain. We don't go down. We don't have a ramp. We don't have a cage. So if you're testing technology, if you're here testing asset tracking or collision avoidance, oh, I forgot my screwdriver, oh, I need my mechanic, you just walk back out and get it.
Right, yeah,
That's what makes us so easy. You don't want to call a bigger mining company and say, I want to work on a project on your site.
Yeah, yeah.
Because
Not
for
gonna-
one thing, these guys are really good at pulling ore out of the ground, and you do not want to slow them down, right?
Right.
That's what makes us so strong at what we do.
Yeah. Okay. Well, I'm gonna step back over with Paul and Shaun and walk through this a little bit more. But thanks for stepping in. I just wanted to kind of get the
Yeah,
perspective.
fantastic.
So thank you, sir.
Have a good day.
Okay, so that was actually helpful coming from Greg because he actually gave a perspective of what's in the mine, like the layout that we actually have here. So, Shaun, can you just before we send you off to a different area, we're gonna do a couple different essentially showcases
Yeah.
of the application. Can you walk us through that?
Yeah. So one of the reasons why Rogers wanted to partner with NORCAT was to help drive the adoption of technology within mining and to help drive innovation. And NORCAT has NORCAT Innovation, and with NORCAT Innovation, one of their, let's call it, companies that came out of NORCAT Innovation, Podco, they designed a water detection system for mining. So with mining, water within the rocks is a huge concern because it's a safety issue. So as you can see here, there's a sensor plugged in. It's running off the private network, and it's detecting the water. And if the water hits a certain level, it will basically trigger an alarm. And then crews will come out and they'll shut down the mine, make sure it's safe, and if it's safe, they'll turn it back on. So this is one of the applications that we have utilizing the private network, and it's run throughout the mine.
And then what's the second?
Second
So
application.
I guess we're doing three actually.
We're gonna do three.
Yeah.
Second application is push to talk over cellular. So with this, we're gonna do a live. Sorry, just gotta get the gloves out of the way. We're gonna do a live
I
call.
just heard off camera. It's called finesse work when you're allowed to take off your gloves. I learned a new term.
There we go. And so we're gonna call my colleague Claude in Montreal from Underground.
Does Claude know we're calling, or is this a surprise call?
He should know that we're calling him, so, but it still might be a surprise.
Oh,
Here we go. And hey, Claude,
Yes.
how's it going? Say hi to everyone.
Hi, everyone.
Okay. So this technology is very, very useful. So this is a video call over PTT. So I can do push to video. I can do push to talk, and it's helpful. This has actually helped me out when I was troubleshooting an issue at the network, and I needed Claude's help, and I was able to just PTT him, and he helped me walk through the issue.
By the way, Claude, you're on a show called Mining Now, just in case they didn't tell you.
Right, and we're gonna turn you around to the camera so everyone can see. Right. Right. So. Thank you, Claude.
Okay, now let's move on to. Thank you, Claude. So okay, now we'll move on to three, which means we're going to bring Paul back in, send you out, and then we're going to connect in the other area of the mine. Perfect. Okay, let's do it. Okay, so Paul, you're now you're doing a PPT call with Shaun.
Hey, Shaun, can you hear us?
Yes, I can hear you loud and clear.
So this now Paul or Shaun, whoever wants to. Well, we hear you a little bit better, Paul. So this could he go pretty much anywhere where the connection is in the mine?
So not only can he go anywhere in the mine, but he could roam with his private network SIM card onto our public network, and he could be anywhere in Canada and be part of the push to talk
Oh,
group.
this isn't just on here. Like
No,
the site.
No.
Oh,
So we have the equipment here. So it is local. The push to talk system from
Right.
TASTA is installed here on site. But because we're also a public mobile operator, we can allow the private network to roam.
Wow.
So think about a use case where you might be, there's always the mine site, and then there's usually a regional office or a
Yes.
head office somewhere.
Or
So
something.
maybe the general manager's off site, maybe there's some type of decision or an incident that needs to be discussed. Using the push to talk with a Rogers private network allows users to be off site and also communicate with the same groups as if they were on site.
Wow, it's amazing. Shaun, do you still hear us loud and clear?
Hear you guys loud and clear.
All right. It's pretty. I didn't realize I didn't realize it would. Again, my terminology. I'm using the word pivot into the entire network. So it's local and it's outside the network.
It's both. That's the power of the system. We can keep all the traffic local if that's what you want. Some people want a very closed system.
Yeah.
But within heavy industry and mining, there seems to be use cases where something's leaving the site. Someone's going in a truck off site, but may need to stay in touch. So we can offer the best of both. You can be on the private site, but we can also allow it to roam using the private network SIM card onto our public network.
Yeah. Paul, just before to wrap up this interview, I guess the question I would ask is if you're watching this and you're going, okay, we want to start the conversation. What is their expectation? How do you approach that first call? Just maybe some basic questions that they should have already answered or that they should be prepared to answer. Can you just sort of tee that up for anybody watching?
Yeah, well, Shaun mentioned earlier in the interview, the number one thing we get asked about is coverage. So know where do you want coverage, number one. So where do you want us to have a signal on your particular site? The second part of that question is what applications do you want to run and how much bandwidth or what's the performance you're expecting when we get there? Because there's two factors. One is the coverage. We can engineer for coverage. The second aspect is performance. How much throughput do you want? 30 megabits, 50, 100 megabits, download, upload speeds. What are all the requirements of your use cases? Something like a water leak detection, very, very small amount of data, right? So we can engineer for if it's just a typical sensor network. Generally, it's a middle ground. So know where you want coverage, know what type of performance that you're looking for, and then, if possible, give us a sense of what's important. So kind of get your applications by level of importance. So generally there are things that are sort of mission critical, and then there are things that in network terms are more store and forward, that if the network wasn't performing, as soon as it comes back, that device would reconnect and send its data going on.
Right.
So something like communications would be mission critical. You want that operating all the time.
Yeah.
And something like a sensor is generally store and forward, and it doesn't need to be on the network all the time. So coverage, performance, and give us a sense of what's really important to you and what's not.
Yeah, that's perfect. Okay, thank you a lot. Thanks a lot. Thanks for having me actually come out here, coming all the way from BC to do this. It's been a lot of fun.
I'm really glad to have you on site. It's great to be on the show again.
Yeah,
Appreciate it.
thank you. And thanks, Shaun. He's off camera now, but thank you very much for all the work he did putting this together as well. And just a quick note, if you're watching this episode, we're going to be doing another episode on the Rogers private network. With a company called Turnkey, who they deliver a lot of the cables.
Yeah, Terry from Turnkey. I think you're going to be meeting him. So Terry did a lot of our installation work here. They're highly specialized companies that can work in an underground facility, and Terry does a great job.
So that's all going to be filmed on this network, but this is going to be remote. So he's in now I'm forgetting.
Thunder Bay.
He's in Thunder Bay. Our production team is going to be in BC, in New Westminster, BC, filming it, and I'll be here at the NORCAT Training Center, Underground Center. So it's going to be, we're going to have connectivity. We're going to prove it right now. And it's all going to be in HD. So thank you very much. See you on the next episode of Mining Now.